Good afternoon, everyone. I'll be talking today about some work done as part of Annex 8 of the Great Lakes Water Quality Agreement. Specifically, I'll be talking about an update to a groundwater science report, which was released in 2016. I'm the Canadian co-lead for Annex 8, while the co-author of this talk, Howard Reeves, is the US co-lead. However, I want to acknowledge the writing team for the report, which includes several scientists from federal, provincial, and state governments. And I also want to acknowledge the Annex Subcommittee for their guidance and input to the report. Writing for the report is well underway. Many chapter drafts are complete. But before going on to talk about the update report, it would be worthwhile to review some of the big picture conclusions from the 2016 report. These, and the priorities that are identified by that report, which I'll talk about in the next slide, served as the launching points for the update report. I'm sure these points will be obvious to this group, but I'll touch on them as they set some of the context. Groundwater is important for enhancing water quality by doing such things as supplying relatively uncontaminated water, regulating temperature and oxygen in streams, and supplying coastal wetlands. But if it's contaminated, groundwater can have the opposite effect, and we see both of these effects in different places in the Great Lakes Basin. Groundwater is also important for processing contaminants. Water moving through different redox zones along the continuum between groundwater and stream water can help to degrade some contaminants. And the converse here is that if groundwater with long residence times becomes contaminated in a way that degradation isn't occurring, this can become a legacy source of contamination. And such contamination can be technically challenging and expensive to remediate. And of course, there are important gaps in our understanding of these processes in the Great Lakes Basin. The 2016 report is very comprehensive. The update report is not an attempt to rehash everything covered in that report. The fundamental science discussed in that report is largely relevant today. A link to the report is here, and I invite you to take a look if you haven't already seen it. The aim of the update report is to identify continuing gaps or emerging issues and highlight progress towards the needs identified in 2016. It's not a report card on progress. Many or most of the issues are continuing efforts, and they're not checkboxes in nature. The 2016 report identified several priorities to advance our understanding of groundwater. In the interest of time, I won't read these out, but as I alluded to earlier, while important progress has been made, none of the research needs from the 2016 report were checked off, as it were, as they are ongoing needs. For example, we can't expect in the short term to fully address the need for more complete monitoring, for example. For today's talk, I'm not trying to be comprehensive, but I'll touch on some of the highlights, both advances and some remaining gaps from the update report as they relate to some of these priorities. One of the identified priorities from the 2016 report was to assess the geographic distribution of groundwater contaminants relevant to Great Lakes water quality and the efficacy of mitigation efforts. There is a wealth, and an increasing one in terms of what's available, of groundwater quality. There's also progress on bringing together some of these data sets, but this can be challenging, if not impossible, well, or at least to make meaningful in some cases. This is in part because groundwater is typically monitored for specific purposes, not for assessing overall patterns in groundwater relevant to Great Lakes water quality. For example, much of the groundwater monitoring that is done is for deeper drinking water. Such monitoring may not align with the monitoring needs to support the Great Lakes Water Quality Agreement. In the case of nitrate, for example, drinking water wells in a region may be low in nitrate, while shallow groundwater, which exchanges much more readily with tributaries draining to the Great Lakes, may be very high in nitrate, and this can result in a misleading picture. Other monitoring associated with contaminated sites, which is of course important, but it's not ambient monitoring, and it doesn't give an overall picture of groundwater quality as it relates to Great Lakes water quality. I think this is going to be an important question that we'll have to deal with going forward. And the second point, there have been many advancements in contaminated related work, bringing together many types of information to generate more complete pictures. And also, this isn't on the slide, but there have been important advancements in sensor technologies for groundwater. However, these haven't been applied in a big way in the Great Lakes Basin yet, but it is something that should be advancing. Several priorities identified in the 2016 report related to regional scale understanding, specifically to advance the assessment of groundwater discharge to surface waters, and to advance monitoring and surveillance of groundwater quality, and to develop scaled up models of groundwater quality. Some of the issues I talked about related to monitoring also applies here, but some other highlights worth talking about. Some work is being advanced in examining how land use and land management relate to groundwater nutrient fluxes. For example, a study by Robertson used relationships between land use and nutrient loading, combined with more site-specific research to generate relationships between these variables on a larger scale. However, these have to be done with caution, as we often don't have sufficient appreciation of both the spatial and temporal heterogeneity of things that influence groundwater processes. And this was something of a theme emerging in many of the chapters in the update report, that generalizations often can't be made until we have a better understanding of the fundamental processes at the relevant scale. In terms of modeling, progress has been made. A coupled groundwater surface water model for the Great Lakes Basin has been published. There have also been some modeling studies using ensembles to improve climate forecasts and how they relate to groundwater surface water interactions. Local scale priorities mentioned in the 2016 report included a need to advance research on local scale assessment of groundwater surface water interaction, and to develop better tools for monitoring, surveillance, and local assessment of groundwater surface water interaction. Related to these, there's been some interesting work done to integrate nutrient databases with GIS information. For example, work by Roy et al. And Spolstra et al. Used such approaches to estimate septic nutrient loading to surface waters. And work by Oldfield used local data combined with GIS approaches to scale up and estimate septic inputs at broader scales. There has been continuing appreciation in the importance of the hypereus for transport and transformation of nutrients and contaminants. However, to our knowledge, advancements in our understanding of these processes in the Great Lakes Basin specifically haven't been done in recent years. Another priority identified in the 2016 report was related to the role of groundwater to aquatic habitats. Groundwater can be important to many types of habitats, often providing stability or refugia in terms of chemical or thermal conditions or oxygen concentration. One of the places where groundwater is of critical importance to habitat is in coastal wetlands. And there's been work to map and classify coastal wetlands across the Great Lakes Basin. as well as approaches to standardize the assessment of coastal wetland conditions. And of course, groundwater is important to the base flow of streams, and such base flow is often of critical importance to many stream organisms, including sensitive fish species. In the US side of the basin, work by McKenna was done to develop a classification system for rivers, which included an estimation of groundwater inputs using summer base flow. The 2016 report also identified a need to better understand how urban development influences groundwater. There have been several studies on urban groundwater, which are outlined in the update report. However, as described, also described is the fact that generalizing beyond a specific study can be difficult because both the urban infrastructure as well as the local hydrology influence greatly urban groundwater processes. Also, groundwater is often not monitored at all in urban settings, and the need to assess this has been identified. Other interesting highlights were about how certain types of urban management, for example, green infrastructure, can have unintended consequences for groundwater quality. Other work has pointed out the need to better understand sewer exfiltration and potential associated risks to water quality. While some of the update report's purpose was to address the priorities in the 2016 report, some emerging issues were also identified. For example, and as I'm sure many of you are well aware, PFAS have been receiving increasing attention, and some progress has been made on sampling and identifying contamination from these substances, though this is by far incomplete. Phytoestrogens and neonics also weren't included in the 2016 report, and this significant concern around these chemicals has been highlighted in the updated report. And similarly, groundwater contained ecosystems weren't part of the 2016 report. However, they are starting to receive increasing attention. Some of the work includes investigations into impairments from toxicity, incorporating the use of genomic tools to study organisms in these ecosystems, and the effects of land use change and how these organisms may affect or be affected by changes in hydraulic properties of groundwater flow systems. And as mentioned in the previous slide, studies on how newer urban management practices may affect groundwater have been done, but much more work is required on this front. The update report also details some major needs and gaps. Some of these are related to emerging issues, while others are continuing gaps. As touched on earlier, there's a need for baseline monitoring to provide a more relevant picture of groundwater quality than can be provided by existing monitoring systems. There's a need to stitch together, where possible, existing data, though this comes with the caveat that in some cases, seemingly similar data sets may not be conducive to meaningful assimilation. The role of groundwater in storing, transporting, and transforming contaminants in the Great Lakes Basin is needed, as well as assessing the efficacy of potential mitigation efforts. This also includes improving modeling of groundwater transport in the basin. Also, as touched on earlier, urban groundwater processes are inadequately understood, and advancing this understanding was identified as a major need. And of course, climate change will act as a modifier to all of these and will be both critical as well as a complicated challenge to address. With that, thank you for this opportunity to speak and for your time. I'd be happy to take some questions.